Hello, I'm Roger Bisbee from the Skill Builder channel, back with another little rant. Well, what I'm talking about today is squeaking floors, cracking ceilings, bouncing floors. We've been getting loads of correspondence from people. They're telling us that they've moved into a relatively new house, and as they walk across the bedroom floors, it's creak, creak, squeak, squeak. How can they fix that problem? Also, they've got micro cracking along the ceilings. Now, it seems to be something which is prevalent in new houses, so much so that there is actually a specialist company that goes around fixing these problems. Basically, they rip up the floors in the bedrooms, they put down a framework, they connect the ceilings back to the joists, they put in extra reinforcement to stop the floorboards moving, and they fix the problem. Disruptive? Well, a little bit. You've got to clear out your bedroom, you've got to take up the carpets or whatever, you've got to rip up the floors, put this system in, and then of course they put it all back as if they'd never been there. Some of the big house builders are actually taking it on the chin and hiring these companies to sort these things out under the various warranties that you get with a new house, whereas other builders are running a mile from the problem and delaying and prevaricating and basically just trying to wear people down so that they get fed up with asking the builder to sort the problem out and go and sort it out for themselves. So what are we talking about here? We're talking about joists. This is basically what floors are made up of. The floor goes on the top and the ceiling goes underneath, as we all know. If you've got a big guy up here, right, he's got no legs. If you've got a guy walking around out here, you can see that you've got a point load on here. But not only have you got a point load, you've got a live load. You've got a person who's walking basically from joist to joist to joist, putting pressure on that joist. Now, when they test these joists, say to about 450 kilos, that's a dead load. But of course, when you've got a live load walking, this guy doesn't weigh 450 kilos, but he's moving. And as he's moving, he's putting that little bit of bounce on there. That causes the floorboards to squeak. It causes the ceilings to crack. One of the problems with floors is that you put all this wet timber into the floor. All these timbers arrive on site, they're soaking wet, they've been stored outside, they go into the building, and when they go into the building, they start drying out. And as they dry out, they shrink. So with the best will in the world, when the builders have put all those joists in and they've set them out all nice and level, they may have got a nice string line across them, got them as good as they possibly can, bearing in mind there are variations in these floors, and of course they have to look at the joist and work out which way the crown is. In other words, if the joist is going across like this slightly, that's exaggerated, but you see what I'm saying. So they need that to go at the top so that it bends downwards, and they diligently do all that, and hopefully the whole thing flattens out and evens out. Over the years, we've moved away to a certain extent from the natural timber, the stuff that grows on trees that should be a lot cheaper than it is, and we've gone for engineered joists. Now, engineered joists offer some great advantages. One thing is they don't shrink. They should arrive on site dry, they should be kept dry, but basically the components of the engineered joist are such that they won't cause problems with shrinking. They're also extremely uniform. So if we look at the engineered joist of old, if you like, what we call the I-beam. So instead of having a solid bit of timber, we now have, this is looking end on obviously, we now have something like this. And this is what we call the cord here, and this is what we call the web. Remember that, World Wide Web. So that web is generally made of something like OSB or even MDF. Cry horror, think my floor's made of MDF, no wonder it creaks. But actually, when you look at it, that is a very, very stiff element in any floor. That is very hard. If you get a piece of MDF, you get a piece of OSB on end and you try and bend it, you will not bend it. They use a piece of that. If I draw it along the side, you'll see a piece of OSB like this. OSB is that stuff that looks like Weetabix, basically. So this cord is along the top there, and this one is along the bottom. That's, you know, a good system. It works to a certain extent. They thought that would overcome most of the problems. The trouble is with this, that you got guys notching through the tops when they wanted to lay a pipe or something through there. Not often, but you did get it. And you also got them hacking great holes in here to get their pipes through, if you imagine there. Now, it is marked up to tell you where you can actually safely drill these joists, but of course guys want to put their pipes where they want to put their pipes. They do weaken them a little bit. But the other thing that happens is that they're not great in a fire situation. In a fire situation, they're far worse than timber. They're very quick to burn through, which is obviously not a great thing. So these I-joists or I-beams are still around and still used, but they have been kind of overtaken by what I consider to be a far better invention, and that is the metal webbed joist. Now here we have the same cord. I'm looking at this sideways on. So we've got a cord at the top and we've got a cord at the bottom, and both those are very good quality stress graded timber without knots in it. So those two cords are very, very important. And then what they put here is galvanized metal. See little holes in it, and that fixes, that's pressed with a hydraulic press on both sides of the joist, so that it forms a familiar arch, and then the next one goes up and so on. So if anyone was following my video from the previous week about the strength of an arch, you can see what's happening there is that we've got a top load on here, but it's being transferred across, and as it's being transferred across, it's hitting there, and then of course there's another one there. So it's working in compression, it's working in tension, and it's holding that joist very stiff indeed. Now the other thing about these joists, the really great thing about them for plumbers and electricians, is you can get pipes through them. You've got all these lovely voids here where you can put pipes to your heart's content, cables, anything you want can go through the middle of those joists without having to hack them around. So there should never ever be any need for somebody to cut into that cord in any shape or form. Now, the other intriguing thing about these joists, there's an awful lot to learn about these joists, by the way, and I'm convinced that a lot of people fitting them never ever read the manual, which is a great shame because it's full of all kinds of interesting information. Doesn't matter whether it's the MyTech Posi joist, whether it's the Eco joist, whether it's the Easy joist, they all give you an abundance of information. Now, you can actually, if you've got a wall here, you can actually hang that joist, if that goes out a little bit longer there, you can hang that joist just on the top without that being connected to the bottom, which is a fantastic thing because it means that can be built into the wall, that can butt up against the wall, doesn't even have to butt up really solidly against that wall. But what we do want to stop is we want to stop any kind of rotation and movement. So when you do this, you kind of make sure that the whole thing is joined by perimeter noggin round the edge, and also if it's between the wall, if we've got a wall like this and the joist is sitting in that wall, we want a bit of solid blocking there and there if we can. But there's all kinds of different requirements for that, so check those out because this doesn't always apply. One thing that does apply is you should obey and follow the manufacturer's instructions. They work all this out. You give them a drawing of the house and they work out where the joists go, what size the joists are going to be, what spans they can cover, and also where there's any supporting walls or anything like that. So absolutely marvellous, and they will turn this round in a matter of days for you. We don't get shrinkage, we don't get any kind of warping, we don't get bounce because these are a lot stronger. They can cover far greater spans, which is great these days because people want to live in bigger rooms. They don't want small rooms with walls in between supporting floor joists up. They want a massive great span. They want to go in there and live basically in an aircraft hangar. So these joists lend themselves perfectly to that kind of application. Surely there must be a downside. Well, in a way, the only downside of these things is that they're installed incorrectly. Somewhere in this joist is a post, a timber post, going between those metal webs, and into that post you have to have a long piece of timber. So if I was looking at the floor joists from the above, this would be one joist. So if you're looking at those floor joists from above, there's your wall and there's your wall. Through the middle here we need a continuous piece of timber which is provided by the manufacturers of the joists, and that timber is what we call a strong back. A great name, isn't it? Now that timber should be nailed to that post all the way along. The problem is there's two things. One, the guys don't put them in and they get to the end and they see this bit of timber and they just saw it up and chuck it on the skip. And the other thing is that they don't always nail them properly to this post, because what you've got to use is 90mm nails, which generally means firing them in with something like a Paslow gun or any of the other lovely nailers that we've now got, gas nailers, electric nailers, you name it. But anyway, the idea is you fire that in. But of course, with this web being in the way, it's very difficult to get your whacking great gun in there to fire those nails in. You can do it at an angle, but it's just one of those things that is a little bit of a pain. Sometimes these strong backs are fitted in, but they're not adequately nailed. So the idea of the strong back is that it's transferring the vibration between the joists. In other words, you'll dampen the vibration. As this fat bloke treads on this joist here, the strong back transfers his load, his vibration along the joist, so it evens it out to a certain extent. So if you've only got a point load going on that one bit of joist, what's going to give? Well, obviously you've got a piece of floorboard going over the top and you've got a piece of ceiling going below. And those two are going to flex as the person walks over. So it's very important that we put those strong backs in. And a lot of what they're doing when they come around and do these remedial works is effectively, without putting in a full length strong back, because it's very, very difficult to do, they kind of just thread a bit of timber in and join all those bits of timber up. So effectively they put the strong back in and they put a kind of H-frame in and they support the floors. That's the first thing that they really ought to do but don't always do, is to put that strong back in and fix it properly. The other thing is, these joists are made with a certain camber. Just like I was talking about with the timber joists, there is a bow upwards in these joists, and that is built in. When they actually make them in the factory, they bend the piece of wood very slightly, they nail metal webs into the side with the hydraulic press. When that joist is loaded, the tendency is for it to want to flatten out, for it to actually go into kind of an arch, if you like, and it's pushing out at the end. So if that's put the right way up, that does a great job. If it's put the wrong way up, it's worse than having no camber at all, because you've basically got a trampoline below. It should never happen, because these should be marked up this side up. But what have we got? We've got people on site who can't read, who don't care, who just want to get the job done, chuck a couple down, realise what they've done, and then don't bother changing it. If those things are done, if the guys are diligent, this is a great system. It has another great advantage in that it doesn't transfer noise, vibration noise, from the top to the bottom. So these are kind of slightly acoustically dead, if you like. They will dampen that sound. So it's a great option if you can do that. The other problem, I would say, is that they put these joists at 600 centres, which basically means that there's 2 feet or 600mm between each joist. So as we look at them end on, put there, they're putting 600 between there and there. 600 is what they deem to be okay, because it will support the load, certainly. Across the joist, you won't get the deflection. They put a very heavy weight on that, and 600 will support it evenly loaded across there. How about that floorboard? That chipboard floor, which is by far and away the most popular choice of flooring for the new builds and all these kind of places, is often only 18mm. Now, if you put 22mm in, you've got a fighting chance, because you've got a little bit more stiffness. And also, similarly, down here, we've got a piece of plasterboard, which is, again, 12.5mm, or the old half-inch board, as we used to call it. Now, that should be, to my mind, if you're going 600 centres, you need a bit of 15mm plasterboard going across the bottom there, because that just gives it a little bit more support. And if you don't do that, what you should do is put a noggin in between each joist to support the edges of the plasterboard. Not in the middle, but along the edges where you've got 2 sheets of plasterboard joining. A piece of timber between those 2 pieces will stop that movement. But again, that's not often done. So you can also put a noggin at the top here. They have what they call Z-clips, and those Z-clips are exactly what they say. They hang over the joist like that. They sit down there, and the noggin goes in and the floorboard goes on top. Now, if you do that, if you use either 22mm chipboard or you use noggins with Z-clips, you can solve a lot of the problems. But do they do that? Well, no, because it costs money and it takes extra time. We've got 600mm centres, we've got inadequate flooring, and we've got inadequate plasterboard at the bottom. And the other thing that should be done, and is not always done, is that these floorboards that we have here, which are basically 8x2 in the old money, or 2.4x600 floorboards, they join up like that. And if it's been worked out properly by the builders, joists will run across there and they will pick up the ends of those boards. So you never get a situation where you're joining a board, two boards, halfway across between the joists. So we never want to see that. We want to see every one of those boards landing on a joist. And because you've got a much better bearing, basically this flange that goes across between the joists, that's the old I-beam, but you know what I mean, it's the same thing, that is 76mm. And if you compare that to a piece of timber, which is often only about 45mm, you can see you've got plenty of room to bring those floorboards nicely onto the top of the joist. Now what they should also do is to run glue all the way down there, because the polyurethane expanding glue we get now takes up any kind of discrepancy. We won't get a discrepancy generally on these kind of joists because they're engineered and they're perfectly true and flat. So you could in theory use something like PVA, but it's a lot easier just to squirt that polyurethane glue all the way along the top before you put these boards down into place. And the other thing that must be done, and is not always done, and we see this time and time again, is those tongues and grooves between those boards. There's a tongue and there's a groove, if you like. There's a kind of arrangement like that. And then this board has got a tongue that goes in there. They should be glued. And of course that takes time again. That's one of those things. The guys just want to nail the boards down. They just might put a token squirt of glue along that joint and then ram it in. But if you glue that properly and you glue that properly, then actually nailing it or screwing it down, which is a far better option, is not all that essential. In other words, you can screw down around the edges, all the way around the edges, and you can put a few screws in there, but you don't have to go to town on the screws. And the great advantage of not going to town on the screws is that it reduces the noise transmission. So we've got a lovely bed of polyurethane adhesive going all the way along these joists. We've got all the tongues and all the grooves glued up. The whole thing is absolutely perfect and squeak free. You won't get cracking ceilings, you won't get squeaking floors if you just take care of these few simple things. The metal web joist is a great innovation, and unfortunately it's being brought into disrepute, if you like, slightly by the fact that people aren't fitting it properly. If you go into joist hangers, you've got to make sure you're tight into the backs of the joist hangers, not leaving great gaps. So everything needs to be done with a little bit of care. And very often when you see these joists, when you see the ends of them, you'll see where the metal web starts, if you like. There is a block of timber here, and that block of timber is so that you can nail the joist hangers to the side of it. But there is what they call a horn on here, which is a little bit, and that needs cutting off so that it's flush with that post, with that end piece of timber. And if you cut that off, it means that that joist goes back further into the joist hanger. And if it goes back into the joist hanger, you can nail, let me just draw what the joist hanger looks like. And the joist hanger has holes in here. If you bring that back so that that piece of timber, that post, is hard against the wall, it means that you can nail properly through. But if you don't, if you leave those horns on, then basically you've got this bit of wood sitting out here somewhere. Not quite as bad as that, that's an exaggeration, but if you imagine it only came in halfway across there and you were trying to put nails in, it would be a bit of a hit and miss affair. So it's all down to detail. I'm sorry if that got a bit complicated, some people can't understand that, but basically in a nutshell what I'm saying is, great idea, these joists, if they're fitted properly, if the builders are diligent, if the jobs are inspected properly by the site agent as he's going around just checking everything's been done right, there shouldn't be this, what I would call an epidemic, if you forgive me using that word in these times, an epidemic of squeaking floors, cracking ceilings and callbacks, which often result in a lot of disruption. So just another little evil of the modern world, if you like. We get an innovation, which is a good innovation, and it's undone by human error. We've got a lot more human error coming up on Skill Builder. I'm not one to just go around randomly dissing people's work, because I think that's an easy sport. Anyone can go into a house and walk around and go, this is wrong, that's wrong. And a lot of tradesmen run a mile from doing that because it doesn't actually do you any good. It's easy to talk a good story. But I would say that we have been getting a lot of correspondence from people who've bought new homes who have got a whole catalogue of problems, and we're going to be doing a little bit more digging and delving into that and naming and shaming some of those big house builders who really are making huge profits but aren't doing the job. So I'm Roger Bisbee. Come back and see us again on Skill Builder. I'll have another rant for you. You can never run out of subjects in the building industry.